All right, let's get right into it. If you've ever written any code, you know that feeling. When you find yourself typing the exact same lines over and over and over again. It's not just boring, it's messy, and honestly, it's just asking for trouble. Well, today we're going to talk about the one core programming concept that's designed to fix that problem for good. So check this out. Let's say we want to sing the bingo song 3 times. The brute force way, just write out the 5 print line statements and then copy paste them twice. I mean, yeah, it works, but look at it. It's clunky. And even though to our eyes it looks like 3 simple commands, the computer is actually running those 5 lines, then running them again, then running them a 3rd time. That's 15 lines of code it's got to chew through. And you're probably sitting there thinking, there has to be a smarter, cleaner way to do this, right? And yep, you are absolutely right. There is. And that better way, the hero of our story today, is something called a procedure. This is the fundamental tool that lets us package up our code so we can use it again and again. It's how we solve that whole repetition problem, elegantly. So what is a procedure exactly? Well, simply put, it's just a bunch of code statements that you've bundled together and given a name. You might hear people call it a function, subroutine, or a method. Don't worry, they're all basically the same idea. The big concept here is you write the instructions once, you name it, and then you can just use that name to run the code whenever you want. It all starts with what we call the definition. Here, we're defining our sing bingo procedure. The best way to think about this is like writing a recipe. We're laying out the step-by-step instructions for the computer. We're basically saying, hey computer, from now on, whenever you hear the command sing bingo, this is the recipe I want you to follow. Okay, so once our recipe is written down, we can call it. And this is where the magic really happens. Just look at how clean and readable that is. Instead of that big block of 15 lines, we've got 3 simple self-explanatory commands. Every time we call sing bingo, the computer just goes and finds that recipe we wrote and follows the instructions. Beautiful. And what's really cool is how powerful this becomes. I love this example from the source material. Think about a knock-knock joke, right? Imagine you made a little procedure for knock-knock, another one for who's there, and a 3rd for banana. With just those 3 reusable pieces, you could make that joke go on forever. You could make it painfully long with hardly any new code. That's the power of procedures. So why does this matter so much? I mean, yeah, it saves you from typing, which is nice, but the real win here is about fixing mistakes. Think about it. If you find a typo in your bingo song, you don't have to fix it in 3 different places. You just go fix the one master recipe, the definition, and it's fixed everywhere. This is absolutely key. It's what makes building big, complicated programs even possible for us humans. Okay, so our sing bingo procedure is pretty cool, but it has one big problem. It's totally rigid. It does the exact same thing every single time. But what if we wanted to customize it? What if we wanted it to be a bit more flexible? Well, that brings us to the next level of this whole thing. This is a perfect example of what I'm talking about. Look at the before on the left. It's the same problem all over again, right? We're writing basically the same line 3 times, just changing the name. But now look at the after on the right. One clean, elegant procedure called say hello that handles all 3. The secret? We found a way to pass in that one little piece of information that changes each time. And that piece of information we pass in has a name. It's called a parameter. You can just think of a parameter as a placeholder, a little blank spot inside your procedure that's waiting to be filled in. I love this idea of it being a customization slot. You're giving your procedure a blank that you can fill in with different info every time you run it. And here's the best part. You're not stuck with just one customization slot. You can have 2, 3, 10, as many as you need. So here, this report grade procedure needs 2 things to do its job: a student's name and their score. By passing in both, we can get a super specific, custom report with just one simple line of code. This is where that Mad Libs analogy from the source material just hits it out of the park. Remember Mad Libs? You fill in a noun, a verb, an adjective. Imagine a procedure that takes 11 parameters like that. Every single time you'd call it, you could feed it different words and get a totally new, completely ridiculous story. That's what multiple parameters unlock, this incredible power and creativity. All right, so our procedures are getting pretty powerful. They can do stuff, they can print text, they can perform actions, but there's still something missing. They do their job and then that's it. They don't give us anything back. What if we need a procedure to do a calculation and then hand us the answers so we can use it somewhere else? Let's go back to our grade reporting procedure. Printing a nicely formatted report is great. But what if I don't want the whole report? What if I just need the final numerical score? Maybe I want to calculate the class average, so I need to get Sally's score, which is 90, and then Wilbur's score, and so on. Right now, our procedure doesn't actually hand me that number. There's no way to get it. And that's the problem that a return value solves. A return value is exactly what it sounds like. It's a value that your procedure computes and then literally sends back to whatever part of the code called it. And let me tell you, this is a total game changer. It's what transforms your procedure from a simple command that does something into a powerful calculator that gives you something back. The magic all happens with one simple keyword, return. Take a look at this calc score function. It takes in the number correct, it does the math, and it gets a final score. And then that final line, return score. That's the magic ticket. That's the command that says, okay, I'm done. Here's the answer. Send it back. So let's walk through exactly what happens here. Step 1, we call our function and we tell the computer, hey, whatever answer you get, I want to store it in a new variable called Sally score. Step 2, the function does its thing, it calculates the score, and it comes up with the number 90. Step 3, and this is the key moment, that returned value of 90 effectively replaces the function call itself. So the computer just sees the number 90 there, which brings us to step 4. The line becomes var Sally score equals 90, and the result is stored. That's it. So why is this so incredibly important? Because it lets our procedures talk to each other. We can take the result from one function and then feed it in as a parameter to another function. This is exactly how real, complex software is built. You create lots of small, reliable, little building blocks that can hand answers to each other to create something huge and powerful. Okay, one quick but super important heads up about the return keyword. When your code hits a return statement, it's like a mic drop. The function is over. It immediately stops and sends the value back. Anything you write after that return line is what programmers call dead code. It will never, ever run. It's a really common mistake when you're starting out, so just remember, return is the grand finale. So let's zoom out and put all these pieces together. We've talked about defining procedures to stop repeating ourselves, using parameters to make them flexible, and then using return values to get useful answers back from them. The big takeaway here is that these three concepts, procedures, parameters, and return values, are the primary tools we have for managing complexity. They're how you take a massive, overwhelming problem and systematically break it down into a series of small, understandable, and solvable little pieces. It's the ultimate divide-and-conquer strategy for programming. And I want to leave you with this fantastic quote because it really gets to the heart of why this all matters. We don't write procedures for the computer's benefit. A computer is perfectly happy running 1,000 repetitive lines of code. We write procedures for our benefit, to make code readable, to make it manageable, and to empower us, the humans, to build incredible things. So that leaves us with a final thought. With these fundamental building blocks in your toolkit, what massive, complex problems that once seemed impossible now look like something you could actually tackle, one procedure at a time?